All right, so what we have here is a question from exercise 8A, and this is number 1E. And it's asking you to find the area between this function, which is the tangent of x over 2, and the function y equals 1, or the relation that. So let's just quick remember what that's going to look like. So this is the tangent of x over 2. This here is y equals 1. And the thing this question's asking us to find is that area right there, okay? So in order to do that, one of our first steps is going to be, we got to figure out where these two things cross. So where is the tangent of x over 2 equal to 1? Well, tangent of pi over 4 is the same as 1. So the tangent of x over 2 is equal to tangent of pi over 4, which means that x divided by 2 has to be the same as pi divided by 4. So x is pi over 2. So what that means is that what we are being asked to find is the integral from 0 to pi over 2 of the upper function, which is y equals 1, minus the lower function, which is my tangent function, so that's what this problem comes down to. Now, I'm going to split my integral just because I'm super lazy, and I don't have anything that's below the x-axis, so it makes sense for me to split the integral. Pi over 2 of the tangent of x over 2 dx. Very quickly I can solve this one. So this is just going to turn into x evaluated from 0 to pi over 2. Well, that's just going to be pi over 2, because when x is 0, we get 0, right. So we got our first part done. Now, we have to do a little bit of work on this second function. So in order to do this work, I'm going to rewrite 0 pi over 2. I'm going to rewrite the tangent of x over 2 as the sine of x over 2 divided by the cosine of x over 2. And then what I'm going to do is I'm going to apply a u substitution. My u is going to be the cosine of pi over 2, which means, well, I'm going to calculate not pi over 2, x over 2. So I'm going to do du dx is the same as negative sine pi over 2 times 1/2. Making the switch here, I get dx is the same as negative 2 over the sine of pi over 2. Again, when you divide by this fraction, you flip it. So the 2 goes on top. Right. So I've figured out what my definition of du is. Before I do my u sub, I'm going to have to calculate some boundaries. So I'm going to evaluate u on both ends. So I'm going to go from 0 to pi over 2 real quick. So the cosine of pi over 2 divided by 2 is the same as the cosine of pi over 4, which is root 2 over 2. So that's one of my new bounds on u. And then the cosine of 0 divided by 2 is just the cosine of 0. And the cosine of 0 is 1. So using this information, getting it all together, I'm going to end up with negative, I'm going to put my new bounds in, well, root 2 over 2 is less than 1. So my bounds are going to flip like that. And then I have the sine of x over 2 divided by my u times -2 over the sine of x over 2, again, just pulling this in, du. Clearly, that cancels, this and the negative are going to cancel, and I'd be left with a new integral that I could rewrite as 2 square root of 2 over 2 to 1 of 1 over u du. And now I just have to kind of go through and find that integral. So that integral is going to be 2 ln of u plus c. And again, evaluating from root 2 over 2 to 1. Subbing back in what my u is, I get 2 ln of the cosine of x over 2 from root 2 over 2 to 1. So looking at this would turn into 2 natural log of the cosine of 1/2 minus 2 ln of actually, I didn't have to convert my bounds now that I'm thinking about it. Cosine of 1/2. No, I shouldn't have converted my bounds. Ha 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 ha. I can just do my substitution here. So if I do 2 ln of the cosine of pi over 2, and then I evaluate this from 0 to pi over 2, I should have it. Because that would turn into 2 natural log of the cosine of pi over 4 plus c minus 2 ln of the cosine of 0 minus c. C's go away. Cosine of 0 is 1, so this turns into minus 2 times the natural log of 1 is 0. And this would turn into, the cosine of that is 2 ln root 2 over 2. Yep. So then, oh, that is painful. So I get pi over 2 minus that. And I think that is our answer.